Knowing how to create an insanely powerful GPT right now puts you in the top 1% of those that will fully leverage the opportunity presented by the new release of the OpenAI's API Assistant. If you're not yet familiar with technology, you're not alone. I was in the same position when I first learned about it. However, by the end of this video, you not only understand how to create incredibly powerful GPTs, but you also learn how to develop your own Sales Assistant GPT. This will give you an idea on how to create specialized AI tools designed to deliver substantial value to your company, business, or clients. Anyway, in case you're still confused, meet Emma, our AI personal sales assistant. In just 20 minutes, I'll show you how to create Emma from scratch using Python and OpenAI's Assistant API. She can analyze your company's sales data and calls, find information on new leads by searching the web, provide answers to certain questions by leveraging data information stored in your CRM, and even make recommendations to close more deals. Now, before I go more to Emma, let's go over a fast explanation on what the OpenAI Assistant and its API is. The OpenAI Assistant is simply a collection of tools and functionalities that developers can use to build their own AI assistants. And the API gives you the ability to leverage three powerful tools and its capabilities. The first tool being Retrieval is simply being a tool that acts as an OpenAI-powered semantic search engine, allowing developers to easily create assistants that can query information from uploaded documents or stored knowledge bases for answering domain-specific questions without the hassle of managing databases. The second tool being the Code Interpreter, which grants AI assistants the ability to generate and execute Python code directly from the self-hosted sandbox. This unique capability empowers assistants to generate responses based on the outputs of the executed code. The last tool being function calling, which pretty much allows developers to expand their applications and have it complete specialized tasks beyond the core assistant capabilities. By utilizing these custom functions, aka specialized classes or models that are created by the devs themselves, developers can use these functions to find unique processes or calculations or actions, like for example, they can create functions performing complex data manipulations or to integrate with an external service to extract certain information and so on. Then you can use this API to seamlessly integrate these custom functions into the conversation flow and execute these defined actions based on user input. Now that we've broken down the basic components, let's go into a quick little demo showing what Emma can do and what the final results of what we'll build will look like before we go into the full coding demonstration. Yes. Here we have the Emma chatbot installed in Microsoft Teams. I'm going to go over all the functionality that Emma provides that I'll go over in the video. The first function I'll go over is the retrieval functionality. We'll use this functionality to have Emma answer questions and make analysis on all the sales calls the company has, which we recorded in the PDF documentation. So we can ask something like, based on all the sales, based on the lead size special customers you talk to in the sales call, rank them 1 to 4, which would be the best leads, aka most likely to buy our services, pay the most amount of money, or will seem like they'll continue to work us in the future, and give us a reason and also rate those leads from a 1 to 10 score. So I have that question right here. Copy and paste. Okay, these are the exact things I mentioned. Enter. And now you can see it gives a response. After reviewing all the available data from the sales call, here is analysis and ranking of the leads, which each being rated on a lead score from 1 to 10. Kim, lead score of 9 to 10. Kim is highly engaged, eager to move forward with the proposal, and shows readiness to review and proceed with the project. They are satisfied with the presented price and payment structure and are ready to initiate the project, indicating strong buying intent and potential for a long-term partnership. Carl, lead score of 8 to 10. Expressed interest in customization and integration, value technical insights offered for the project. Patrick, lead score of 7 to 10. Walter, lead score of 6 to 10. So you can pause this and kind of read through all the breakdowns that the chatbot gives us. Now, the next functionality I'm supposed to go over deals with function calling functionality. So we have two cases where we use this functionality. First case is where we have Emma pull information from a database we have created in Airtable based on what the lead user inquiries about. So this information will have stuff like when is the lead's next meeting notes, how the lead was found, and so on. So we might ask a follow-up question like, we'll kind of ask the question like this so we can get details on what more information on our lead. So when our next meeting with Carlo is, what we should prepare with Carlo. So this will let us quickly query information and find information on our leads, and pick Carlo since it was one that gets the highest rated list leads that we have than previous question. So enter. So he gave a response. Next meeting with Carlos scheduled for November 25th, 9 o'clock Eastern Time. For this meeting, Lozy, the salesperson assigned, will focus on initiating the pricing and discussing the security access of their chatbots, including how we should ensure the information is secure. Carlos is a company that has 800,000 employees. We found Carl at the AI conference. If you need to get in touch with him, his email is carl@github.com, so it gives you all information on our leads. Now, the second functionality we have, or the second case where we use the function call functionality, we ask Emma to pull information from the internet or web on leads we don't have in our database. So, for example, let's say I'm at a dude called Liam Otley in a conference and a discussion on business opportunities with him. Afterwards, I want to find out some information on him to see how good of a lead is. I can ask a chatbot a question like this. During an AI conference I attended last week, I had an opportunity to meet up with a gentleman called Liam Otley. He mentioned he runs an AI automation agency and expressed interest in potential partnership. Can you please conduct some research for me to find out more about his company? Especially, I want to know the name of his company, its official website, and a brief overview of what the service or product he offers. So, get that. See, in a sense, I found information about Liam Otley and his company, Mornison AI. Liam Otley is the founder of Mornison AI, which is a full-cycle AI development automation partner. They're specialists in AI development, aiming to take business to the next level and incorporate AI into their systems. Their official website is Mornison AI. As for what the company offers, they offer a comprehensive AI service that helps startups and enterprises build cutting-edge products that use artificial intelligence to optimize efficiency and accelerate growth. It says they guide through the whole process. So it tells you when it's founded, where its headquarters, what they specialize in, and so on. So it gives you kind of overview of the Liam Otley and his company, so you can get more. You have more information or more idea of who he is and how good of he is a lead. And then the final question is, the final functionality we have is a code interpreter functionality. This allows Emma to create items like graph based on the numerical data we have stored in Excel sheet by generating its own code. So if we want a visual representation of our company to data, we can ask them in like create a bar graph comparing potential deal amount for each customer, each lead. So and now you can see it gave you a bar graph comparing the potential deal amount each lead will bring in. So pretty much how much money we'll get off from each lead. You see David is around 7,000, Patrick is around 30,000. So you can see all the deal amount each lead could bring in. So now since I showed you a short demo of how Emma works, let's go into showing you how I built this thing. Now, the first assistant that I'm going to go over is what we're going to use to answer questions and inquiries of our made-up company sales calls by retrieving information from docs that have all the sales information written into them. Let's have a quick look at what's in that sales doc. You can see that it has 7 sales conversations, and all the sales conversations are centered around a salesman trying to sell a chatbot to a lead. Each sales conversation having its unique elements when it comes to price objections, timelines, common objections, feature requests, and so on. Now, if we go to the code, you see that in that first line that we have their API key, which we have cited in our .environment file, so nobody can see it, so I don't share with you. And then we have in the next part of code, we have the client equals OpenAI.client code. This code is pretty much what we're using to create a Python object called client that interacts with the OpenAI's API. Object simply being a container that holds the data and instructions on what an object is and what an object can do. For example, you might have an object called login that has classes that allow you to set a username and password and change that password through apps like email verification. And if we look at the back at the OpenAI client expression, the OpenAI part simply refers to the library we're using, the client refers to a specific class in that library. Now, if we go down, we have their create assistant function, and pretty much we're using the create assistant. Since OpenAI bills you per assistant you create, in the first couple of lines, we'll have an if statement that checks if a text file called assistant ID exists. If it does, we leverage the capabilities of our pre-existing assistant by reading and using the assistant ID that's written in the assistant text file. And if it doesn't exist, we'll use the client.beta.assistant create method to call methods in the client class in the OpenAI library that practically act as a wrapper around one of OpenAI's endpoints that will create assistant with the attribute described in the client.beta method. And if we actually go to the OpenAI documentation, you can see the OpenAI endpoint, the code needed to utilize the OpenAI endpoint, and all the parameters you can use are sent to the request. And if we go look back at our code, you can see the parameters we have. We have the name, sales call knowledge bot. We have an instruction, which is our prompt that we're going to feed it, and we cite that over here. You're a sales chatbot responsible for retrieving information and so on. We have our tool, which is the retrieval tool, which is going to give us the functionality to extract data from our docs. And then we give it a file D from the file create and attach to the assistant using the client.filesCreate method. And then I'm going to run the code soon, but before I run the code, I want you to look at this left-hand side. You can see that you can see all the files over there. And I also want you to look at my OpenAI Assistant tab. You can see right now we don't have assistant at all. Now I'm going to run it. Okay, in the first line, you can see that we're creating an assistant. Since we don't have assistant right now, instead of using a pre-existing assistant, it's gonna create assistant. And you see on the left-hand side, it creates a text file used to that. And this is the file we'll use to pull the assistant ID from anytime we want to use a pre-existing assistant instead of creating a new assistant. And we go back to my OpenAI account and we refresh. You can see a newly created assistant that wasn't there before. And you can even see the prompt over here in the assistant ID. Now let's go back to the next part of our code. So the next step is create a thread. We do this by using the thread.create method. Thread simply being the conversation session between the assistant and the user, aka the context window that has all the messages stored. Once we create a thread, we'll create a user message. The user message being what are the most common rejections we face in our sales call. And then we'll add that message into our thread. We'll also have a user role attached to it to signify that message is sent by a human user. And then next, we'll use the client.beta.thread.run create to invoke the thread. In other words, we're pretty much sending a request to OpenAI's API, triggering the assistant to process the current threads of conversation history, which right now has our user message in, and then generate a response to that user message. And while we're waiting, we'll use run.retrieve to check on the progress of the status of that run, or the invocation of that assistant. And you can see in our console we have a bunch of waiting for assistants to be complete statements printed out. And when that thread is finally completed, it'll capture a response. But until then, it'll be kind of in a process status. And when it does complete, we'll list all the messages using thread.message list. And then we'll eventually loop through all the messages and get the latest message in the thread, which will contain the assistant response. And if you need any more insight on what threads or runs are, this is all in the OpenAI's documentation. Now, going back to our code, you can see that we have some added logic to create our message object into JSON format and write into a file name message.json to inspect or look at. And if we go back to our print statement, real cool. We also have this for a run. For a run object, we run into a JSON file too. Then look at later also. And then if we go back to our print statement, you see that we have message.role capitalized, which is pretty much code. Simply capitalize the first letter of the string, and then the role is going to print out where the message is coming from, like who's sending that message. And we see here it says the assistant sent the message, so that's the person that's sending the message to the assistant. And then we also have message.content. That's kind of how we're going to loop through and find the latest message. We have message.content 0, so we're going to get the latest message in there. And text.value is where the exact message is. So if we go and actually look at message.json, we can see value, and we have to see the actual response the system gave us. And we see the value is inside the text bracket, which is inside the content bracket. And if we look at the run status JSON file, we can see stuff like the run ID, the status, the tool calls used, the thread ID, and so on. Yeah. And then we go back to the console, we actually see the system response. And we see that its answer to one of the most common objections we face in our sales call is stuff like higher upfront payment, flexible payment structure, concern about return on investment, long-term support and maintenance costs, and so on. Now let's go over how you can actually integrate the assistant functionality into a chatbot. So if I go over the Replit here, you can see the sales calls.py file, and you see a lot of the code we already went over before. Just like before, we have the client object, and we have the create assistant function that helps us create assistant or use a pre-existing assistant when leveraging ID. We also have the prompt.py file, which will have our prompt or assistant instructions. And then we have the secrets tab, which will have our API key in. Now, if we go to the main.py file, this is where we'll set up our API endpoints that we call when we want to start up our system or grab its responses. I'll go over more why after we go over the code. You can see in the first couple lines, we're trying to create a Flash application, then create a client object that we use to interact with OpenAI's API. And we finally will call that create assistant function and load the system that's been created in the create assistant function in the sales icon file. And if we go back, you can see that we're returning that assistant ID. So that's the assistant ID that the main.py file will use. Then we create two endpoints. One is a start endpoint, which will create a thread when we hit a request, and the other endpoint being the chat endpoint, which will pull the thread ID and the message from that request. The message being the message the user sends to the assistant from the request that hits the endpoint. Then we'll use that information to run the thread and return the system response. So now let's run the code. Then after we run it, you can see the web view tab. And after it loads after a while, you can see that it opens a web page called not found. And here, we're going to go here and we're going to copy the URL. And you see the little URL, show you the little URL that we copied. Here's the URL that we copied. Now, this will go to the next part, which will explain the whole reason why we moved the code into Replit and create endpoints to hit. So I'm going to open up Voiceflow. Voiceflow is a software that helps us build AI agents and chatbots through low code and flow designers. Right away, you can see that we have a box called create a thread, which has a URL we saw before, plus the endpoint that we mentioned in the start/start. So when I click it, you can see that we're sending a GET request to it. You can see the full URL. You can see that /start endpoint that we mentioned in our code. And as I showed before, we're trying to extract the thread ID values from that response. So that start endpoint is going to create a thread ID. When it creates a thread ID, we want to extract that thread ID from that start endpoint. So kind of show you what that endpoint will send, I'm going to hit it in Postman real quick, give you an example. So send, and see when I send that GET request, you can see down here below, you see that thread ID value. That's the value that we're going to be capturing when we hit the start endpoint. Then if we succeed, we'll send two messages. One is, hi, I'm Emma, your company internal sales. And we'll send a response to that, and it will capture that reply that user sends. So that probably be the question that the user wants to ask the chatbot, and it'll set equal to the last utterance value. This pretty much will be the user message that we want to give to the assistant so it can generate a response to it. Then those two values, the thread ID and the response that we capture, that or aka the last utterance, are going to be values that we send to the chat endpoint as a request. And as before, the chat endpoint is specifically used to run threads and send the response the system gives. And let me show you an example by sending that request and get the chat endpoint through a curl command. So let me copy and paste this thread. And now you can see that it sent a response. So that gives you an example of what kind of the body will look like. You can see the message that we sent. You can see the thread that we sent as the body, and then you can see the response that it sends back to us. One of the leads that we have sales call with is somebody named Patrick. Now, going back, once the assistant returns a successful response, The next pause called send response will first clean up the response and make sure it's sent in a good format. For example, we see the response we created in VsCode before. You can see it has a bunch of brackets and stuff inside it. That code will kind of clean that up, remove all the brackets from it. So when we actually run it, it will just be clean format and clean text. No extra stuff that we don't need, or extra syntax that we don't need. The next step in there is pretty much gonna print out or show the message in the chatbot or chat window. So after it generates response, we can visually see the response that it gives the user. And after that, it will loop back to the capture user reply so that you can repeatedly ask that chatbot questions. And then we also have, I guess, kind of a failover. So if you see these failed box steps, anytime that there's a issue in the back end, it will route to these failure boxes and say something like fail to generate new response, ask your question again, or contact support. So you can customize that and have responses in case that in the back end your chatbot fails or something. And now let's have a quick demo. Let's run this. Run tests. And ask chatbot what are most common objections faced during sales calls. And you can see it sent a similar response that I sent before. Cost concerns, return on investment, flexibility in payments, long-term spread enhancements. That's kind of similar to what it sent before in VsCode. Flexible payment structures, high upfront payments, concern about return on investment, maintenance costs, and so on. So that's kind of the example of the first assistant that I created, the first functionality that I showed you in the demo before. Now that we've seen the basis of how assistants work, let's go over some of the other functionality that assistants have, which I mentioned earlier in the video. Let me show you my other project in Voiceflow, which I use to build chatbots with not only retrieval functionality, but the function calling and the code interpreter functionality also. Now, the biggest difference here is that it has a classification block that will route you to a chatbot with a flow to another component pretty much, or route you to another component. And all this component does is it uses the AI tags, which will categorize the user messages into 4 different categories. Airtable, if the user asks for a specific question about the clients in their database. Sales, if the user asks questions about recorded sales calls. Data, if user message asks for data insights or graph based on data collected and recorded by the company. And info, if user asks questions about information about potential leads or partners not recorded in the database yet. And based on where the AI categorizes the user question, it will route the response to a specific endpoint using if conditional statements. Each endpoint hosts an assistant that is specialized to answer the category the user message is in. And so you see all these blocks, and each one uses its own assistant. With the last response being its own block that we'll use to display the response in the chat UI and loop the flow back to the original point or back to the user capturing block, allowing the chatbot flow to repeat the process after the user asks another question. Now let's quickly go over the code blocks and all the different assistants we have. Let's go over the code for Airtable functionality. Like described in the classification block, this is used for answering questions on when is the next meeting with the client, what notes are important to know for the meeting, what is the size of the client's company, and so on. And this information is pulled from my database in Airtable low-code SaaS software. Now let's quickly take a look at what we have in Airtable. If you can see in our database, we have stuff like lead name, lead email, next meeting, meeting notes, company size, and where a lead was found. And now if we look at our code, you see the first thing you see is that we have a function called get records by lead name. And all it's doing is taking whatever value the lead name is equal to, which is our argument, and filtering through the row your lead name occupies using Airtable API. So it sends all the information you need to answer the user message to the assistant. So how does the assistant know to run this function? How does it know what value to pass to the function? If you look at my code, you can see that I have a variable called toList. This is where I will define my function for my OpenAI Assistant. Now I put here is the function name we're using, the description of the function, which is used to help the system determine when to run the function, and the property section where we define the argument that will pass to the function. This is what we're going to use to take the string, aka the user input we sent to assistant, pull the lead name from the user input, and turn it into a JSON format so we can pass that value into our function. And you can see that we have tool lists defined in our system we're creating. And if we go to the main.py and we go to our run status, for function call, there's a period where function status will be equal to required action. This state is where the system will determine the name of the function and the argument to pass. And while it's in this required state, it will check the function name we set in the tool list, and then if the name is set to the right function, it will get the argument that we set in the tool list, which we're converting from JSON to dictionary. Then we'll take the function we set up in function.py and call that with the same argument. And like I mentioned in the description, the argument will be the name of the lead we're trying to get information from. After the function runs, we run the thread using the submit to output method with the output value as one of the parameters, so the system can use the value the function returns to help answer the user questions. I'll write the run status into the file and print the argument output to give you a deeper look at what's happening. So let's go to Voiceflow and test this. First, let's run this first. Let's start up our server. Okay, let's test this assistant functionality, this Airtable functionality. So let's go here. Let's go to start. Let's go to run. Let's go to run test. And let's ask, what should I prepare for in my next meeting with David? And this is what we get. For your next meeting with David schedule, you should prepare for a basic demo of one of the chatbots we previously built. It's for ratings. Be aware of that company, so it lists all the data that we have on David. Make sure to have the demo tailored to company size and prepare to answer any inquiries he might have regarding implementation scalability and support. So, and then if we go back, let's go back and look at our run.tools JSON file, and we see that we have a required action bracket, we have the submit to clause bracket, and then we have a function bracket, and this is where we retrieve our argument from and the function name from. And then to the outputs we have the output that we retrieved when we sent an API request to Airtable. So this is the response Airtable give us back, and we also have the argument. So if I copy this and take this, copy, and then go test this in the UI also. Next, what do I need to prepare for in our next meeting with David? What do I need to prepare for in our next meeting with David? Run that. It accesses the submitted output, so it doesn't have access to the function that our endpoint has access to. So it's going to access the submitted output, and it's going to be in that required action state until we give it output. So I'm going to give it the same output that Airtable gave us when we were running our code. So copy and paste. Submit. Continues to run. And we'll just wait. It's in progress. We'll wait until it gives the output, and it gives us the output. And we see that output gives us, for the company with David, there are a few things you need to repair. A little different, but pretty similar overall. So you say, be ready to present a basic demo of the chatbot, familiar yourself the size of the company, read interaction with David particularly. So a little different output, but the same overall meaning. Now I have another function that allows people to find information on leads not in their database by searching their name in Google and finding their LinkedIn profile and scraping data from their profile and their company profile so they can answer any specific question on these leads. So if you look at my code here, I have a JSON to readable summary function. I have a search LinkedIn profile function. And I have a get LinkedIn profile and company data function. And the main one is the LinkedIn and search company data function. That's what my function calls going to be calling. And then the rest of the functions are pretty much kind of sub functions in that function that we called. So I won't go into too much more detail on this, but I'll show you an example to kind of show you what they can do. So our test subject is going to be this guy. He's the CEO of Voiceflow, the software we're using. So I'm going to copy and paste this name. Now I'm going to run test. And before I do that, I have to remember I need to run this. Now I'll say and now he gave us a huge response. So it says Brandon Ream is a prominent figure in the commercial field of AI. He's currently the CEO of Voiceflow that specializes in democratizing creation of digital assistants. Under his leadership, the company blah 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 experience as a blah blah was undertaken, teams including raising blah blah. So you can also learn more on their website, voiceflow.com. If you're looking for direct content, so I guess it's direct content and his website, and talks more about his company size. So it gives you a bunch of information, track record. So that's just an example of what my LinkedIn assistant can do. The final assistant we are using is going to leverage code interpreter to create graphs based on sale-driven data we feed the assistant. We feed the assistant the sale data through an Excel file. We take a quick look at our Excel file. You see that we have the deal orders, company status, contract, deal owner, future clients want implemented, and the most important part, statistical part, is deal amount, expenses, property deal, for referral potential, and so on. Now, if we take a look at our code, that we have some extra code there. So, Assistance does allow you to read Excel files or take in Excel files like how it can read and take in sales.pdf files, but instead I'm going to use code to turn the Excel sheet into more readable format for the assistant instead. So pretty much what this code is doing here is that it's reading processing data from the Excel file, converting it from a more usable and readable JSON format, while also cleaning and remapping any unnamed columns. Then it'll write all that data to a text file called output. Then we'll add the retrieval function as an option along with code interpreter so the assistant can read that file. And we look at our main.py file, you see that it checks if an image is created. If an image is created for that file ID and read that file ID, then it'll use that to take the data from the image, read it, and write into a new file that will set as a PNG file. And once it gets that file, it will take that file and host it in another API endpoint right here. And what we'll do is that we're gonna take that image URL from that from our chat endpoint. So if you look at our voice flow, you see what it takes. You see it takes the image URL, and then if it gets the image URL, it's gonna go to this box here, and then this voice allows you to do is, if you give it an image URL, it'll visually show that image in the chat UI. Now we're gonna run a test. Let's see. So, so You kind of see it. You can see the deal amount, and you can see if you go to the Excel sheet, it matches up. So 3,000, 6,000, 2,000, 3,000, 6,000, 2,000. So it matches up. And if you also look at here, another cool thing, look here, we can also see it making, GET requests to OpenAI's endpoint that we brought up earlier before. So it just shows you that code is making a call to the endpoint. An overview of OpenAI's Assistant API functionality. If you thought this video brought you value, drop a like and subscribe. And if this video still left you with a lot of unanswered questions, you can join my Telegram group down below. It's the best place to reach me and ask me any questions if you still need help on this topic. Also, let me know if you're still interested in a video to show you how to integrate your chatbot into applications like Microsoft Teams and Slack, like I showed you in the demo at the beginning of this video.